Okay, directive gain. Directive gain is same as the gain of the antenna. Gain of the antenna. Now we have already defined that antenna is a passive device. Okay, antenna is a passive device. Passive device means what? It cannot provide gain. Actually, what is passive device? Passive means it cannot provide any gain. But how the antenna is providing gain? Okay, actually it is not providing any gain, but as compared to other antenna, it is providing gain. Okay, as compared to other antennas, it is providing gain. Say for example, when if you have some student, average student, okay, okay, average student is there. Okay, when everything, all other student in the class is very worst, then we'll call it as, we will call that average student as a best student. We'll call that average student as a best student. Or otherwise, you take another scenario. We have one average student. For all other student in the class is very good, very intelligent. Then we'll call that average student as a worst student. Like that only. So like that, here antenna gain means gain comparison with some other antenna. Gain means what? It is providing some gain as compared to other antenna, but at the cost of something else. At the cost of something else. Can anybody tell me what is that at the cost of something else? நம்ம சொல்ற ஆண்டனாலாம் கெயின் ப்ரொவைட் பண்ணோம் as compared to something else, but இன்னொன்னு ப்ரொவைட் பண்ணாது. Can anybody tell? Or otherwise, can you simply tell me what is the gain of the antenna? Not bandwidth. Or simply, can you tell me what is the gain of the antenna? At least you tell me that. I will tell you remaining things.
Field due to reference antenna.
Field divided by field due to reference antenna.
Divided by field due to antenna, sir. Corresponding antenna.
What antenna? No.
Antenna, sir.
சொல்றீங்க மறந்துட்டீங்க. Field due to practical antenna divided by field due to isotropic antenna. Isotropic antenna. Okay. But at the cost of something else, I will tell you now. I will tell you what is that cost. Okay. Generally, gain means always with respect to isotropic. Gain means what? With respect to the gain term itself is defined always with respect to isotropic antenna. With respect to isotropic antenna. Okay. Now I have 10 watt power. I'll take the same example. I have 10 watt power. Okay, I stand somewhere here. I can go anywhere on the imaginary circle. Okay, I observe my field. Okay, observe my field. Okay, so this is say power due to isotropic. Okay, I will get some power or some electric field or something. I'll call it as P isotropic. Now my question is, now I replace this antenna. Now I replace this isotropic antenna. This is isotropic antenna. This is practical antenna. Okay. Now I replace my antenna, but this antenna will radiate power only in a specific direction like this. But what is constant? I am having same power, 10 watt only. I am having same power. Here also 10 watt is total power. Here also 10 watt is total power. Because I want to make a communication only in this direction. My transmitter is here, my receiver is here. My receiver can be anywhere in this area. Okay, my receiver is here. Now my doubt is my receiver can be anywhere here. It can be here or here, it can be here. Okay. Now my doubt is, suppose I am here, my receiver is exactly here. Okay. Now what is the power due to the practical antenna? In which case I will get more power? Solunga sir, in which case I will get more power?
Second one.
Second one, without any doubt you have to tell, that is very clearly second one, because this is also radiating 10 watt, but it is radiating only in a specific direction. Please think it of like this, sir. You take your light, ordinary light bulb is there. குண்டு பல்ப்லாம் பார்த்துருப்பீங்களா ஓல்டன் டேஸ்ல, அந்த பல்ப் இருக்கு. அது என்ன பண்ணும்? எல்லா டைரக்ஷன்லயும் ரேடியேட் பண்ணும். இதுவே இங்க லேசர் இருக்குன்னு வச்சுங்க. லேசர் என்ன சார் பண்ணும்? லேசர் ஞாபகம் இருக்குங்களா? லேசர் ஞாபகம் இருக்குங்களா? லேசர் இருக்கு. இப்போ இப்போ நான் மெஷர் பண்றேன், அதாவது இங்க இருந்து மெஷர் பண்றேன், அதே டிஸ்டன்ஸ் அகைன் டிஸ்டன்ஸ் சேஞ்ச் பண்ணாங்க, இங்க இருந்து மெஷர் பண்றேன். எந்த கேஸ்ல சார் எனக்கு அதிக பவர் கிடைக்கும்? செகண்ட் கேஸ்ல தான் கிடைக்கும். அகைன் அதிக பவர் கிடைக்கும். அப்படி இல்லைன்னா என்ன பண்ணோம், லேசர் கேன் கோ டு தி லாங்கர் டிஸ்டன்ஸ், லேசர் கேன் கோ டு தி லாங்கர் டிஸ்டன்ஸ், பட் அட் த காஸ்ட் ஆஃப் வாட்? பட் என்ன சார் ப்ராப்ளம்? சி ஆஸ் பர் டெஃபினிஷன் உங்களுக்கு லேசர் வந்து கெயின் தர மாதிரி தெரியும், பிகாஸ் பவர் டியூ டு லேசர் இஸ் ஹை, light received from the laser is high as compared to light received from the ordinary bulb, but at the cost of what? At the cost of beam width. At the cost of what? Beam width. Okay, you are getting gain at the cost of beam width. Okay, the gain, see, that is very, very important. You are getting gain, at the cost of beam width. What is beam width? Beam width means what? Here you are radiating your power in entire direction, because suppose if some user comes, if you stand here, you will not receive power at all. Okay, for a practical antenna, if user is in this direction, you will get very good power. If you stand here, you will not get power, but in case of isotropic, you can get the power. Okay, so you are getting gain in case of practical antenna at the cost of beam width. Okay, because isotropic antenna is radiating in all direction, but sometimes we do not need radiation in all direction. In practical purpose, we need radiation only in the horizontal plane. Even in the horizontal plane, I need radiation pattern only on a particular side. Then I get more gain as compared to the isotropic antenna. I get more gain because in practice, our communication is fixed, sir. We know transmitter, we know where will be the receiver. Then what is the need of transmitting power? Everywhere. Okay, what is the need of transmitting power? Everywhere. So that's why we can concentrate our power only in a specific direction. Okay, so what is directive gain? It's very simply how effectively the practical antenna concentrate the power towards the receiver. That is the gain of the antenna. Okay, what is the definition, real definition of the gain of the antenna? How effectively practical antenna radiates, not radiates, concentrates. Anyway, antenna will radiate, concentrates, how effectively practical antenna concentrates power on specific direction, on a specific direction. That is gain of the antenna. That is gain of the antenna. Okay, so that is the gain of the antenna. So there are different definition. Okay, I will write that. So first, very simple one, understandable one is, see the gain, generally they used to put directive gain. Okay, gain, directive gain, because you are getting gain, not everywhere you are not getting the gain. You are getting gain only in a particular direction. That's why this gain is called as directive gain. Okay, you are not getting the gain in all direction. You are getting gain only in a specific direction. That's why this name itself is called as directive gain. In a particular direction only you are getting the gain. Okay, so directive gain. Okay, so directive gain DG is equal to simply power received by practical antenna, power received by practical antenna. Okay, power received due to by practical, not anyway receiver will be practical antenna only, but power received from the power received from the practical antenna divided by power received from the isotropic antenna, power received from the isotropic antenna. Okay, so that is the directive gain. Again, power nu போடலாம், இல்லனா power density கூட measure பண்ணலாம். Power density due to practical antenna divided by power density, because in both the cases receiver is same. Okay, when you do the measurement of gain, your receiver is same. What you are changing? You are changing the transmitter. In first case you are using isotropic radiator. In the second case you are using practical antenna. Second case you are using practical antenna. So what is hint? Hint is receiving antenna is not changed during gain measurement. Receiving antenna not changed. Receiving antenna not changed during gain measurement. Okay, during gain measurement. Okay, so so what is the another definition? In another way also I can write directive gain is equal to PR, okay, power density, okay, power density due to practical antenna, okay, then power density due to isotropic antenna, okay, power density due to practical antenna divided by power density due to isotropic antenna. Or otherwise you can also write like this: what is the radiation intensity due to practical antenna? What is the radiation intensity due to isotropic antenna? Okay, so radiation intensity of practical antenna. In which case our radiation intensity will be high, for practical or for isotropic?
Practical, sir.
Practical, sir.
Yes, for practical. But under what condition? What has to be constant when you do the gain measurement? Total power has to be constant. Huh? Total power transmitted is constant actually. Nan purida? Because நீங்க total power change பண்ணீங்கன்னா எல்லாமே confuse ஆயிடும். If you have some total power, you use practical antenna, you use isotropic antenna, then what is the difference? That's way only you can measure the gain. So what is constant? Total power transmitted is always constant. Please see all our discussion. If I take 10 watt here also I will take 10 watt. Then if I take some different watt here, then that's like cheating only. Okay, once if you want to compare the things, then you have to take same power here in this case. Okay, so
Sir,
yes sir, சொல்லுங்க.
முன்ன ரேடியேஷன் பேட்டர்ன் ஒன்று டிரா பண்ணீங்களா முன்ன கிளாஸ்ல? அதுல அட் தி சென்டர்ல வந்து கொஞ்சம் அதிகமா இருக்கு, கீழே போக குறைஞ்சுனே வரும் சொன்னீங்களா? இந்த கேஸ்ல பவர் கான்ஸ்டன்டா வச்சிருக்கீங்களா எல்லா டைரக்ஷனும்?
இல்ல இங்கேயுமே குறையும், அதே போல தான் வரும், குறையும் பவர்லாம். பட் அகைன் இந்த டிஜியே வந்து கான்ஸ்டன்ட் கிடையாது சார். டிஜி இட் செல்ஃப் இஸ் ஃபங்க்ஷன் ஆஃப் தீட்டா. டைரக்டிவ் கெயின் இட் செல்ஃப் இஸ் ஃபங்க்ஷன் ஆஃப் தீட்டா. புரிஞ்சுங்க, டிஜி வந்து கான்ஸ்டன்ட் கிடையாது. It is also a function of theta. Directive gain is also function of angle. That's why this is called directive gain. In a particular direction you will have more gain, in particular direction you will have very less gain. ஒரு சில அதான் நான் சொல்ல வரேன் சார். ஐசோட்ரோபிக் ரேடியேட்டர்ல எங்க இருந்தீங்கன்னா பவர் கிடைக்கும், பிராக்டிகல் ஆண்டனாவில் எங்க இருந்தீங்கன்னா பவர் கிடைக்குமா? அப்ப அந்த இடத்துல கெயின் வந்து எவ்வளோ? 0. ஸோ ஒரு பர்டிகுலர் டைரக்ஷன்ல மட்டும்தான் உங்களுக்கு கெயின் கிடைக்கும். So here also gain is function of angle. நீங்க directive gain na always fixed னு நினைச்சுக்காதீங்க. Directive gain is a gain, it is a function of direction, function of angle. அத புரிஞ்சுங்க. என்ன சொல்ல வரேன்னா, இந்த கேஸ்ல நீங்க இங்க இருக்கும்போது மட்டும்தான் மேக்ஸிமம் பவரை ரிசீவ் பண்ணுவீங்க பிராக்டிகல் கேஸ்ல. Once if you deviate from this point, then you will get less power. Once if you vary your angle, if you try to go like this, then you will get 0 power. Okay, see your angle, your received power is also function of angle. நீங்க பிராக்டிகலாவே பார்த்துருப்பீங்க. பிராக்டிகலா வந்து when you have மொபைல் டிரான்ஸ்மிட்டர், ஒரு சில ஆங்கிள் இருக்கும்போது உங்களுக்கு பவர் கிடைக்கும், கொஞ்சம் ஆங்கிள் சேஞ்ச் பண்ணீங்கன்னா என்ன கிடைக்காது? பவர் கிடைக்காது. உங்களுக்கு சிம்பிள் எக்ஸாம்பிள் சொல்றேன். மவுண்டைன் இருக்கிற இடத்துல வந்து ஆண்டனா எப்படி ஓரியன்டேஷன் பண்ணிருப்பாங்க பார்த்துருக்கீங்களா? மவுண்டைன் வில்லேஜ் இருக்கும்போது வில்லேஜ் சைட்ல தான் ஓரியன்டேஷன் பண்ணிருப்பாங்க. நீங்க பை டிஃபால்ட்டா மவுண்டைன் சைடு போனீங்கன்னா உங்களுக்கு சிக்னல் கிடைக்குமா? சொல்லுங்க சார்.
No sir.
கிடைக்காது. That means what? The gain is itself is function of angle, function of direction, function of angle. அதனால கெயின்னா டைரக்டிவ் கெயின்னா ஏதோ கான்ஸ்டன்ட் நினைச்சுக்காதீங்க.